Hello everyone, good evening. Here we'll solve some KCET previous year questions chapter mathematical. Any doubts if you have, yes, please write us in the comments section. Clarify them in different videos. And any other chapter of more difficulty, then mention the name of the chapter comments. Then give more clarity on it. Solve and more. Also some important homework chapter. So please install our Sapience. The link has been provided. Here we shall start from very first. Here it is told if P and not R. So this symbol means this symbol means and this symbol means this symbol means whenever this symbol is used, suppose like P, it means that it means if P then Q. If P then Q. P and Q are some mathematical statements. And what do you mean by a mathematical statement? A mathematical statement is a statement. Mathematical statement means it is a statement which is either true or false, but not both simultaneously. Statement which is either true or false, is either true or false, but not the statement which is either true or false, but not both true or false simultaneously. So if a statement is either true or false, then only it is a mathematical statement, and if it is both true or false at the same time, then we will say that it is not a. So here P and Q are some mathematical statements. So here it is told that if P and not R, if P and not R, then not P or Q. So if this statement is false, means that its truth value is false. Truth value is false. So then what are the truth values of P, Q and R? So if this is false, okay. So this statement can also be written as, means if P then Q, if P then Q, this statement is equivalent to that not P union Q. Not P union Q. So then here also this statement can be also written as P and not R, P and not R, then P or Q, that can be written as not of P and not R. Then not P and then there is something called as De Morgan's law. De Morgan's law. De Morgan's law states that we take the not of P and Q, then this is equivalent to not P or if I do negation of means the not of P or Q, then that will be equivalent to not P and not Q. These are called as the De Morgan's laws. So similarly here this I can write and not of not Q, suppose I do, that will be Q. Means negation of a negation will be the same statement. Means the negation of any statement Q, that is same as the statement itself. So these three laws we should use, and this is also a rule which we can use. So this we can write as not P. So if we apply the De Morgan's law, then it will be not P or not of not R, which is R. Okay, so this we should write not P or this or write not P or Q. So this is false. So this is false. So if this is false, it means that both should be false. So since the rule is that whenever we say P or Q, this is so its truth table, if you draw the truth table of P and Q, so that is like P and Q, and here we can write the truth table of P or Q. So P, Q and P or Q. So here P or Q P and Q are some mathematical statements. So if the truth value of P is true, the truth value of Q will be also true. And the truth value of P is also true, then the truth value of P and Q will be also true. If any one of them is false, then this is also false. Both are false. And for this, it is both are true, then it is true. And if any one of them is true, then also it is true. And if both are false, then only it is false. So here, statement this is told not P or R, not P or R, or not P, in this bracket we can remove, not P or R, or not P or Q. So this is false. So when the OR function that is false, it means that each of them should be false. Therefore, both of them should be false. So not P or R should be also, its truth value should be false, and also the truth value of not P or Q, that should be also false. And when OR function that is false, so each of them is false. So it means that not P, that is its truth value is false, truth value of R is also false, and also truth value of not P, that is false, the truth value Q is false. So it means that, so not the truth value of not P is false. It means that the truth value of P will be true. The truth value of Q is also false. The truth value of R is also false. So therefore, the truth values of P, Q, and R are respectively true, false, and false. So option A is the correct answer. Then in question number 2, it is told the negation of the proposition, if 2 is prime, then P is odd. So let us take the statement P as, statement P we can take it as, if 2 is prime, statement Q is odd. So the given statement is, if 2 is prime, then P is odd. It means that if P, then Q. So the negation of this, so if P then Q, this is equivalent to not P or Q. Therefore, the negation of this if P then Q means I can say that is the negation of not P or Q. Here we can apply the De Morgan's law. Is equals to not of not P and not of, that is P, not of not P is P, P and not Q. So P and not Q means the statement is 2 is prime, and P is not odd. So option B is the correct answer. Then in the question number 3, it is told the converse of the contrapositive of the condition P, if P then not Q. Converse of the contrapositive. So the rule is that the converse of the statement if P then Q, is, converse of this statement is if Q then P, and the contrapositive of the statement if P then Q is if not Q then not Q, then not Q. So now converse of the contrapositive. Therefore, first we need to find the contrapositive statement if P then not Q is if not of not Q, then not P. Which means that is not of not Q is Q. So Q, if Q then we have to find the converse of this. Therefore the converse converse of this statement, if Q then not P, is if not P then Q, not P then Q. Means option B is the correct answer. In question number 4, it is told the negation of the statement P and if Q then not R. You have to find the negation of this statement. You have to find, therefore, the negation of this means we have to find the not of this something. That implies, here we can apply the De Morgan's law, that is not P or not of if Q then not R. That equivalent to not P or this we can write not of this we can write it as not Q or not R. Not Q or not. Then here again we can apply not P or this we can write not of, this we can write not of Q and not of Q and R. We apply the De Morgan's law. This will be not P or not of not is the same thing, so that is not P or Q and R. So option B is the correct answer. In question number 5, it's told that which of the following is not true? It is meant by tautology. So here in the option C we see that it is not of P implies Q. So this symbol means implies. It means what? That if P then Q and also if Q then P. So therefore P implies Q. This statement is equivalent to if P then Q and if Q then P. Therefore the negation of this, not of P implies Q, that will be equivalent to not of P then Q or not of Q then P. Now this is equivalent to not of, this you can write not of P then Q or not of P or Q or not of not Q or P. So here we can apply the De Morgan's law, that is not of not P and Q or is not of not q and not p. This is not of not p is p and not q union not q and p. Not q, this is q and not p, or you can write not p and q. So therefore the negation of p implies q, that is equivalent to p and not q or not p and q. So it means that option C is the correct answer. Then tautology means what? Tautology is a mathematical statement. Tautology is a mathematical statement which always results in truth value. Always results in truth value. It means that which is an identity, which is an identity. So, but in the option A and B, it is written that it is a tautology, but it is not true. The option B, suppose, for example, P, if P then Q, this is equivalent to not P or Q, not P or Q, but here it is written P and not Q. It is always false actually. That is why not of not P and or Q, that is equivalent to P and. It means that not of P implies Q, that can be written as P and not. So it is not a, is not a, so option C only is the correct answer, since it is the left hand side is coming equal to the right hand side. Then in question number 6 it is told the negation of this statement is, the negation of this statement is what? So we have to find the negation of P. If P then not P or Q, it means that is equivalent to not of not P or not P. So that is equivalent to, we apply the De Morgan's law, it will be not of not P and not of not P or Q. So this will be not of not P is P, and here again we have to apply the De Morgan's law. This P and not P. So this will be so this we can write P and P. If we apply the associative law, the associative law if you apply, P and P and Q. So P and P means P only. So this is P and not Q. Option D is the correct answer. Then in question number 7 it is told P, if P then not Q. This can be also written as, so this is equivalent to not P or not Q, not P or not P. Option P or not Q. So option C is the correct answer. Then the inverse of the proposition P, inverse of the proposition P and Q, P and not Q. If P and not Q, then R. We have to write the inverse. So the rule is that the inverse of the statement if P then Q is given as if not P then not Q. Therefore the inverse of this statement, that is P and not Q, P and not Q then R, is not of P and not Q then not R. So this is equivalent to, here you can apply the De Morgan's law, that is not P or not of not Q then this will be not P or Q then so option B is the correct answer. Which of the following is not a correct statement? Mathematics is interesting, root 3 is a prime, root 2 is irrational, the sun is a star. So for the statement A, mathematics is interesting. So mathematics can be interesting for some persons, for some other persons. So it means that for some students, mathematics can be interesting, and for some students mathematics may not be so interesting. So it means that the statement A is both true or false at the same time. Statement A is both true and false. Statement A is both true and false simultaneously. So it is not a mathematical statement. It is not a mathematical statement. So it means that option A is the correct answer, since it is not a correct statement. And the statement B, that is root 3 is a prime, its truth value is false. It is false, so it is a mathematical statement. And in the options C also, this statement is root 2 is irrational, whose truth value is true, means that it is a mathematical statement. Option D also, the sun is a star, its truth value is also true, so it is a mathematical statement. So those statements whose truth value is either true or false, that is a mathematical statement. But those statements whose truth value can be either true or false at the same time, that is not a mathematical statement. Option A is the. Then in question number 10, it is told not of not P and Q. This is logically equivalent to. So this is equivalent to, we can apply the De Morgan's law. So that is not of not P or not Q. So not of not P is P and P or not Q. Or P. Option A is the correct answer. No, sorry. P or not Q. Option C is the correct answer. Then in question number 11, it is told the contrapositive of the converse statement. If x is a prime number, then x is odd. So here we can take two statements. Here we can take two statements. Let's say the statement P is x is a prime number, and the statement Q is x is odd. So here the given statement can be written as if P then Q. So then we know that the contrapositive of the converse. So we know that the converse, therefore the converse of the statement P if P then Q is if Q then P. And then we are being asked to find the contrapositive of this converse. Now therefore the contrapositive, we know that the contrapositive of P if P then Q is if not Q then not P. That means therefore the contrapositive of the statement if Q then P is given as if not P then not Q, which implies, which is equivalent to the statement if not Q means if x is not a prime number, then x is not odd. It's not odd. So option D is the correct answer. Question number 12, it is told find the contrapositive of the statement if x is prime number then x is odd. So here let's suppose we take the statement P as x is a prime number, and the statement Q is odd. So then here we can write the statement as if P then Q. So the contrapositive of the statement is P then Q is given as is if not Q then not P, which means the statement I can write it as if x is not odd, then x is not a prime number. So option D is the correct answer. Then in question number 13, it is told the negation of the statement 72 is divisible by 2 and 3. So here we can take one statement P as 72 is divisible by 2. 72 is divisible by 2. And we can take the statement Q as 72 is divisible by 3. 72 is divisible by 3. So then therefore we can take this statement as 72 is divisible by 2 and 3. P and Q. The given statement is P and Q. Therefore, we have to find the negation of this statement, negation of P and Q. Here we can apply the De Morgan's law. So that is not P or not Q. So which implies the statement now can be written as 72 is not divisible by 2. 72 is not divisible by 2, or 72 is not divisible by 3. So option A is the correct answer. Then in question number 14, it is told the negation of the statement all continuous functions are differentiable. All continuous functions are differentiable. So the negation of the statement is some continuous functions are not differentiable. Some continuous functions are not differentiable. So option B is the correct answer. And in question number 15, it is told the negation of the statement for all real numbers x and y, x plus y equals to y plus. So the negation of this statement, I can say that for some real numbers x and y, x plus y is not equal to. That means that option B is the correct. So here we shall end the video on the previous year KCET questions on the chapter mathematical reasoning. So hope all of you have understood the solutions of these 15 questions. If any doubts you have, then please write us in the comments section. Please install our Sapience Education application, where we shall upload some important previous year questions on every chapter. So, thank you everyone.